Question number 47. The diagram below shows a negatively charged rod and is placed between but does not touch identical small metal spheres, R and S, that are hanging from insulated threads. What can be concluded if the rod repels sphere R but yet attracts sphere S? Well, remember, opposites and neutral attract. Meanwhile, like repel. So with that being said, we can figure out that if sphere S is attracted to that rod, sphere S definitely has to be positive, and we know that sphere R is negative because it's repelling away. So sphere R must be negative. Yes, that's true. Sphere S must be positive. Ooh, that seems like it. Let's see what else. Sphere R must be negative. That's true. Ooh, sphere S could be positive or neutral. This is even better. Choice 2 is our answer. Don't fall in the trap and just read the first one, because if so, you would have picked the wrong answer there. Tricky, tricky. Number 48, the amount of electrical energy consumed by a 60-watt light bulb for 1 minute, and it lifts a 10 Newton object a maximum height of how much? So we're talking about electrical energy going into mechanical energy. So the electrical energy is going to equal the potential energy of this particular device. So first, we have to find the electrical energy. Well, there are many formulas with electrical energy because that's with the W. So we have a formula here for electrical energy, and we have all of these formulas here for electrical energy. So in this case, the problem tells us the amount of power and the time. So actually, I just have to use this first version of my formula. Electrical energy is power times time. That's 60 watts times 60 seconds. Don't fall into the trap and use 1 minute. We want time in seconds. 60 times 60 is 3,600 joules. Now this question is wondering, how high can this object be lifted? Well, my electrical energy will equal my potential energy. So my electrical energy is 3,600 joules. My potential energy is going to be mass times gravity times height. Mass times gravity is the weight of the object. In this case, it tells me the weight. That's 10 newtons. So that means my height is going to be 360 meters. Question 49. Microwaves can have a wavelength that's closest to what? Let's head to the reference table. Here at the reference table, we are analyzing microwaves. And boy, does microwaves have a range of wavelengths. A microwave could be 10 to the negative fourth meters, all the way to almost 10, we'll just say it's close enough, 10 to the 0 meters. So let's take a look at what each one of these would be. 10 to the 0 would be 1. You don't move the decimal, so that would be 1 meter. 10 to the negative 1 is going to be 0.1 meter. 10 to the negative 2 is going to be 0.01 meter. This would be 0.001 meter, and then this one here would be 0.0001 meter. So what could this possibly be closest to? Let's look at our choices. The radius of Earth. I think Earth is way bigger than just 1 meter. The height of Mount Everest? Well, everyone would climb it if it was just 1 meter. The length of a football field? That's definitely bigger than 1 meter. The length of a thumb? Well, does a thumb fit somewhere in between 1 meter and 0.0001 of a meter? Yeah, a thumb would be about 1 centimeter or so. So a thumb would be about this, which is a centimeter. So that works. This is a good range for microwaves. Question number 50. Two pulses approach each other in a uniform medium. Which diagram represents the superposition of these two pulses when they overlap? Superposition just simply means to add up the pulses and see what the resulting pulse will look like. This scenario is a little tricky, so I'm going to take this and move it on over and line it up so it looks like that. You can draw this on your page yourself doing something similar. This line here, we're going to represent 0. We're going to say this is positive 1, and we're going to say this here is negative 1. Why do we do that? Because if you add 0 and negative 1, your point will be negative 1. If you add, let's say right in the half here, this would be 0.5. 0.5, and in this location, this would be a negative 0.5. 0.5 and a negative 0.5 gives you a 0. And here you have a positive 1, and this location right here, again, will be 0. So positive 1 and 0 is positive 1. So your new overlapped wave is going to look a little something like this, the one that's outlined here in blue. And I'll do it here in green because green means we are good. So this is going to be the way that that problem is going to look. So choice 1 is our answer. You've completed the multiple choice questions. Click the link to go to any page to redo it and try again. Or click ahead and try some open response with page 11 and 12. Let's get it.